All right, after fighting with my 3D grapher for a little bit, I think I've got it to work out. So I'm going to show here how to find the equation of a 3D line that connects two random points. So I got point A in there, 2, 3, 5. Let's make point B 3, negative 1, comma 4. Okay, so when you're doing the equation of a line in two dimensions, you want to find the slope between your 2 points. And so you do the difference in the y values and the difference in the x values, and you divide them. Here we have three different coordinates. We're not going to divide it in a weird three-step fraction. We're just going to find the difference between each coordinate and use that as our direction vector. So let's do that. The difference of the x values, we're going to go from A to B. So we can call our vector AB with a little direction on it. So let's go from A to B. So from 2 to 3 is an increase of 1. So 3 minus 2. Then we have negative 1 minus 3 for the y coordinates and 4 minus 5. So kind of like how we do y2 minus y1. X2 minus x1, I'm just doing that including z2 minus z1. So our direction vector then is going to be, it went one step higher in the x, it went 4 steps lower in the y, and it went 1 step lower in the z. So then to write my vector AB, just like we did mx plus b or b plus mx, our vector AB is basically going to start with our vector A, 2, 3, 5, and we're going to add our direction vector, 1, negative 4, negative 1. We're going to add that t times. And so I really should use a different notation for this. So let's call this the slope of AB. The slope of AB. Okay, so let's type in our vector, and if we did it correctly, we'll see a nice line. So I'm going to say my vector, is equal to the point that I started at, which is 2, 3, 5. And you can see now I've got my vector going right to point A, and then plus my direction vector, 1, negative 4, negative 1, t. There you go. It's connecting those 2 points right there. And so a line in 3 dimensions is not really much harder than a line in 2 dimensions. You find how much each of your coordinates changed, and you have a starting point there. And so this was really similar to writing an equation in Algebra 1. You just wrote y equals b plus mx. In this case here, our b just is a random starting value, and the n happens to be three-dimensional. So let's do one more example in this video and then call it a day. So I'm going to clear the screen. I'm going to go back up here and change what I've got as my starting value. So let's just make a equal negative 2 and 7 and 0, and then we'll make b equal, I don't know, 5, negative 1, and negative 4. Where did b go? Okay, you can see b is down there. It dropped into the negatives. So there you go. Now you can see a and b. So let's go through the work here. What is my direction vector? My direction vector, essentially my slope, is 5 minus negative 2, negative 1 minus 7, negative 4 minus 0. So that becomes 7, negative 8, negative 4. If I want my vector to go from A to B, I can type it like this. V equals my A coordinates, -2, 7, 0, plus t times my direction, 7, -8, and -4, and it should work. No, okay, maybe I need to type the vector word in there. Just dealing with a little bit of formatting here. There we go. You can see that it's touching one thing. I'm almost there. There we go. Okay, let's try this again. So v equals vector, and I type in -2, 7, 0. That part works fine. Plus t times the vector. Oh, that's right. I needed to hit the times button. There we go. That's what we needed. Of 7, -8, -4. And we did it. It is attaching our two, it hits our A and our B. It may be a little hard for you to see me if I zoom out. There we go. It's attaching A and B. And so that's how you find a line in 3 dimensions. I'm out of time for today, but I will make some more videos soon about extending our ideas of lines to looking at planes and finding the angles between them. But this is some of the basics. Feel free to ask for more videos. I'm happy to make them.